All right, so 8.4, we're going to talk about derivatives of three important functions. Ln of x, b to the power of x, and just log of x, base whatever. So we're going to take a look at those derivatives. I'm going to show you why the derivatives are the way they are by kind of going from first principles almost. Okay? So in 8.4, it starts in our textbook page 376. And the first thing they do is they give you the derivative of ln of x. Now remember, ln of x is the log of x base e. It's the natural logarithm. Because base e for an exponential function in calculus is really important because e to the x is its own derivative. So remember that from a lesson or two ago. Okay? So that's why ln of x, or natural logarithm of x here, ln of x, is of great interest to us in calculus. Okay. So, ln of x. So let's recall that ln of x is, and I'm just going to do this over here in red, ln of x is, as I said, log of x base e. Okay? So what is another way to write log of x base e? So let's say we had, this right here, okay? Log of x base e to the equals y. So what's another way to write this? Think the exponential version. Well, how would we write that? That's going to be e to the y equals x. Okay? So what I've done is I've changed this into this into this. Okay? What are we actually looking for? We're looking for the derivative of y with respect to x. So we're looking for y prime. So guess what we're going to do? We're going to take the derivative of this over here, because it's the same thing as ln of x. Okay? And y prime is actually what we're going to end up with, right? Okay, so what is the derivative of e to the y, guys? What's the derivative of e to the y with respect to x? What is it? Thank you. It's e to the y, because it's itself. And then because this is not x, we have to do chain rule and multiply by y prime. Okay? I'm going to go to Newton notation here now with just the prime instead of the d over dx. Okay? What's the derivative of the other side? Because really we're doing implicit differentiation here, right? What's the derivative of x with respect to x? It is 1. All right? So if we solve for y prime now, or dy dx, we get 1 over e to the y. Well, what was e to the y over here? It's x, so y prime is 1 over x. Hence, the derivative of ln of x is simply 1 over x. It's pretty easy, right? That's easy. Now, to do that derivation, don't worry about it. If you didn't get that, if it went over your head, don't worry about it. But that's y, if you wonder. Now, what about this? What's the derivative of, let me change colors here. What's the derivative, with respect to x, of ln of u? And u, remember, is some other function, let's say. What's the derivative of ln of u? Well, it's going to be 1 over u times u prime, or times d over, I'm mixing my notations here, sorry. Or du dx, which I like Newton's notation better anyway. So ln of u, the derivative of that, is 1 over u times u prime, or u prime over u. Just chain rule. But the big thing is the ln of x, its derivative is 1 over x. Okay, you got that? You got it locked in here? Very important right here. All right. So that's the first big one. Let's go to the second big one, which is, okay, the derivative of an exponential function. So I'm talking about like y equals 2 to the power of x, okay? So this is a base 2. Let's find out what the derivative of an exponential function with any base, okay? Any base. So the derivative of b to the power of x. Do you remember, or do you recall, that we can actually rewrite b, let's rewrite b as Now we're going to have to go back to, let's see if I can find it here. Right here. E ln of x is x. Okay? So if you've got e to the power of log of x base e, it's x. So we're going to use this right here to rewrite this one right here. And we're going to write, so b to the power of x is going to be equal to e to the ln b to the power of x. Because b is the same as e ln b. And if it's to the power of x, we're going to put the power of x there. Okay, so b equals e ln b. Not Elon Musk, but Elon B. Okay? Okay. All right, so let's take the derivative of this. Now, why would I want to take the derivative of this instead of this one? Any ideas? Because we can solve it? Okay, why? What's easier about the right side here? E, right. We have e to some power. So if we have e to some power, the derivative of that is itself. Right? The derivative of e to the u is e to the u times u prime. So if I have e to the u, that's easy. Easy to take the derivative of. So that's what we're going to do. Let's take the derivative of e to the ln b, okay, to the power of x. And we're going to take the derivative. Okay, here's Newton notation again. Take the derivative. All right. So the derivative of this equals, okay, well, the derivative of, okay, so we can write this just as one big thing. So e ln b times x, right? Because the exponent laws say that we can just multiply a power raised to a power. Okay. So the derivative here is e to the power of ln of b times x. So it's itself, but we have to now multiply by the derivative of the inner function, right? So here's the outside function. Here is the inside function, right? And so that is the derivative of ln b times x. So I'm just going to write this down, ln b x derivative. Okay, so let's focus on that one now. So remember, ln of b is simply the logarithm of a number base e. So this is actually just a number. Okay? So if you took the derivative of a number times x, what's that derivative with respect to x? It is just the number. So this is just the number, so guess what? This is the same as just writing this as ln b. Okay? One final step is now to bring back in this. So e to the power of ln of b is the same as b. So where do we have e to the ln of b? Well, we have it right here. Okay? Now again, don't worry about this. If you're like, I have no idea what he's doing. Don't worry about it, okay? I barely know what I'm doing here, okay? I don't like proofs either, okay? I'm just joking. But this is b to the power of x times ln of b. So the derivative, so here we go, this is important. The derivative with respect to x of b to the x, that's any exponential function, is simply b to the x times the natural logarithm of whatever that base is, b. So the derivative of b to the x is b to the x ln b. Pretty straightforward. The derivative of b to the u would be what? B to the u ln b times u prime. Yep. And remember, ln b is just going to be a number. It's a constant. It's going to be a number. Okay? All right, so that's the second one. Here's the third one. Well, let's find the derivative of this third one right here. Okay, so log of x base b. So log of x base b. If that equals y, how can I rewrite this? So I'm just going to rewrite this because I want d of y with respect to x. So I can rewrite this as b to the y equals x, right? So we did that before. Okay? So if we take the derivative of b to the y equals x, so we have b to the y equals x. If I take the derivative of this with respect to x, what do I get? Okay, here's what I get. The derivative of b to the y, did we not just do that one? Well, let me see here. Derivative of b to the x, so the derivative of b to the y would be b to the y ln b times y prime. Would it be that? So the derivative of this, that's like b to the u, so it's b to the y ln b times y prime. Or, again, mixing up my notation, I apologize, dy dx equals 1, because the derivative of x with respect to x is 1. So implicitly differentiating, this is what we have. Okay, get rid of that over there. Okay with that so far? What we do now is we want to solve for this. So guess what? I divide both sides by b to the y ln b. And I get dy over dx is 1 over b to the y ln b. And then I go back over here and I say, hey, b to the y is actually just equal to x here. So this 1 over b to the y becomes 1 over x ln b. Which kind of makes sense, right? Look at this, 1 over x, you see, that's log, okay, 1 over x. Natural logarithm, okay, that was e, all right, okay, so we're close, right? So this is important, here it is, in red. D over dx of log of x base b is 1 over x ln b. Alrighty. All right, so if we're going to differentiate this, f prime of x, here let's say for a, okay, x squared ln x. Okay, so this is two functions multiplied together. So what rule do we have to use there? Product rule, right? Product rule. So what's the product rule is the derivative of the first one times the second plus the first one times the derivative of the second. Okay? So the derivative of the first is, now with respect to x, is 2x times the second ln x plus the first, x squared, times the derivative of the second. What did we just say the derivative of ln of x was? 1 over x. Awesome. So that's 2x ln x plus x. You don't have to factor it. You can take a x out if you want, but that's fine. Right there for a. Okay? All right, what about c? Let's take a look at c. G prime of x here. Okay, so I'm looking at c, and I'm seeing an outside function and then an inside function. Are you seeing that too? All right. So what's the outside function? Is ln of u, basically. Ln of u. So the derivative of ln of u is 1 over u times u prime. So we have 1 over u, which is x cubed, plus 1, times the derivative of x cubed plus 1, which is 3x squared. Now, do I have to do something else here, or is that it? 1 over this times the derivative of this. So we did the outside function, which is this one, and we did the inside function, which is this one. So it's just basically a little, you can just write it together if you want there, and that's it. That's good. Okay. You guys can confirm with the back of the book, see if our answers are looking the same or not. Okay, let's do one with trig here then. Let's do e, I guess. We're on a roll here. So y equals sine of ln of x. I think this is another chain rule situation, right? Chain rule. So we've got outside function, that should be an x there, and we've got inside function. So what's the derivative of sine? Is cosine ln of x times the derivative of ln of x, which is 1 over x. So there you go, over x. Done like dinner. Yeah? That's good. 1, 3ac, 4 abaca, 5 ac, 8a. And here is the textbook for you.